speaker today is Andrew Green. He's a professor in Geological Sciences at the University of KZN and a fractional professor at Ulster University, where he lectures sedimentology, basis analysis, and marine geology. He's authored or co-authored 75 papers, all focused on the field of marine geology. His principal research interests are understanding how the marine geology of shells varies, worldwide. This extends to societal concerns such as future coastal flooding and risk management. Andrew is editor-in-chief of international journal Geo-Marine Letters and an associate editor for Marine and Petroleum Geology. In 2014, he was awarded the NRF, South African Network Coastal and Oceanic Research, Emerging Scientist Award for Excellence in Marine Research, and in 2018 was a Fulbright Scholar to Woods Hole Oceanographic Institute and the Universities of Maine and Texas. In 2019, he was the recipient of the American Geophysical Union Award, Africa Award for Excellence as an Early Career Scientist in Ocean Sciences in Africa. Andrew, if you'd like to go.
Thank you very much, Nolene, and thank you to everybody that's joined us across the vast interweb. Today, I'm glad to welcome you to a talk I thought would be interesting to give in terms of having a glimpse into marine geology from its past, during the heyday of marine geology in the 70s and 80s through to the present, so the status quo, and then perhaps where we will focus on in terms of future marine geological studies in Southern Africa. So I'm going to welcome you guys. Let me just from Durban, which is clearly the warmest place to be. So we're sitting at about 25 degrees today, so a lovely sunny day. So my apology to colleagues across the rest of the country. I believe it's not quite as warm. And we're going to focus today in terms of our talk on the east coast of the Southwest Indian Ocean of South Africa. So looking mostly at the coastline and shelf that we've been mapping for the last, say, 10 years. So to give some context to things, to set the scene, marine geology was really alive and kicking through the 1970s and into the early 1990s. And most of this work stemmed from the University of Cape Town, where there was a very vigorous and really energetic program looking at deep water all the way through to continental shelf marine geology. There was a number of very notable scientists that were associated with this and a number of really important papers that came out. This was funded mostly by collaborative research between the Council for Scientific and Industrial Research and the then Geological Survey of South Africa. And by the mid-80s, this had begun to migrate its way across to the East Coast, so to the University of Natal, which is now, of course, the KwaZulu-Natal. And here we focused mostly on coastal and estuarine work with some shelf studies, notably quite a few from Dr. Peter Ramsey. So this continued through to about the early 2000s under the same premise. There was input from the CSIR as well as the then Council for Geoscience. There was a unit established in parity with that at the University of Cape Town. However, by the early 2000s, the commercialization of these government entities meant that there was a drawback in terms of funding and involvement of students, and which began an implosion in terms of academic activity across the country. So there's actually been a really large hole that's been left in terms of training for students and for postgrad students in particular, moving into the research fields of marine geoscience. If we look across Africa, we can see that there's probably only a few countries here, and I've done a fairly intensive search, that have marine geological programs associated with academic institutions. And by association, I mean that they specialize in both coursework, research, and supervision through to doctoral levels. So Nigeria has 2 institutions. They focus mostly on things that are cost-effective, which is geochemistry of coastal environments or coastal erosion and oceanography. The Kenyan and the Tanzanian institutes, they're having syllabi up for discussion on the internet. It's actually uncertain at present whether or not these people are, in fact, open for business. The University of Cape Town, which was once a powerhouse in marine geology, has slowly let that wane. They now mostly focus on ancient marine geochemistry. So John Compton, who was the professor who undertook marine geological studies, he's since retired. It focuses more, and his role is now more on ancient marine geochemistry and hard rock, Gondwana, and sedimentology. this really just leaves the University of KwaZulu-Natal as the sole institute that provides training from undergrad all the way through to doctoral level in marine geoscience. If we look at the status quo of where we are now in terms of research projects with University of KwaZulu-Natal, as well as collaborations, the blue stars are our collaborations. You can see there's a widespread collaboration across the world. This is principally because there's one full-time lecturer, staff member associated, which is myself, and a developmental lecturer who's slowly learning the ropes and publishing papers. Between the two of us, we really need quite a lot of collaboration. We need to stretch our network so that we can sustain the amount of research that's needed to start generating real interest again in marine geoscience in South Africa. If you can see, we're busy. There's a lot of research projects. So not only, and I'm quite proud of this, not only just focused on Southern Africa, but also now starting to expand elsewhere. So we're doing research in other areas of the world by invitation. So we're starting to grow in terms of our international reputation. So I set myself a 10-year challenge when I started at the university again in 2010. This was after my PhD. This was the extent of the coverage that we had. We had some basic seismic coverage and some basic seafloor mapping. This was done in the mid-2000s. And really, there wasn't much going in terms of what's happening on the East Coast. And today, we've got a fairly substantial amount of data that's been collected. A lot of this has been very fortuitously collected through the auspices of industry. So it's quite helpful that we can moonlight at universities. We can use data in lieu of being paid for services. So we've collected a lot of data over the years. We can see that we have some impending survey work to do. So this is in the sort of southern portions of the Transkei and the southern KwaZulu-Natal coast and off the Tidal here. So this impending survey work has obviously been the product of COVID-19. We'll carry on with that as soon as we can. But on the whole, you can see that we've done a fair amount of coverage over the last 10 years. Again, something which is quite, I think, need to be proud of considering the lack of funding. So there's very little industrial funding available for marine geology, and governmental-wise, it's almost a non-recognized science currently. So, you know, we've really put our noses to the grindstone here. So if we look further afield now, we look across Southern Africa, these are all of the current projects that UKZN is dealing with. So you can see there's a spread of projects that look at things such as deep marine geology, through to nearshore and coastal geology, and mostly on the continental shelf. This is a good industrial relationship here, as well as work. We'll talk about the work that's occurring on the East Coast, work in terms of coastal water body evolution with colleagues at BITS, so Professor Mark Humphreys, and then further afield, things like extreme storm recurrences, etc. So we're quite well spread, and we're spread because we have complete self-sufficiency. So we're the only university in Africa that has the equipment that we do. So we have seismic profiling equipment, multiple pieces of equipment for that. We have ultra high resolution mapping equipment for the seafloor, and we'll talk about what these are. We have remote observation vehicles that incidentally my next door neighbor had built, works very well. Marine vibrocorer to actually core sediments, and we have the full suite of software and computing facilities available to help us process all the data. So we're actually sitting now with a big data revolution, and the data that comes in is enormous. So we're really sitting now with banks of computers that allow us to process all of this. So we're very lucky in that respect. So this equipment really stems from these early observations, and the observations are such that we're interested in knowing what the seafloor looks like. Obviously, we can't peel back the oceans, and so the best way to understand what the seafloor looks like is to get an idea of its shape. Here we have a man who's pretty much doing just that. Standing on a boat, he's got himself a rope in one hand and a lead line or lead tied to the other end, and he's letting that go and measuring the distance along that rope when the lead weight hits the bottom of the seafloor. So you can imagine this is how you are starting to understand what the seafloor looks like from a depth perspective. You take many points like this, it maybe allows you to interpolate between them, and you can get a very crude picture of the high points and low points of the seafloor. What we do nowadays is far more intricate, so marine geologists are akin to bats in that we use the principles of sonar or echolocation to be able to picture and visualize what's occurring at the seafloor. So we emit sounds, the sounds bounce off the seafloor, it takes a certain amount of time, we know the sound velocity, and we can work out what the distance is. So this brings us to the revolution that occurred probably during the wartime, and this allowed us to start mapping the great ocean basins, was going from this, which would have been just breadcrumb trails with a lead line, to using a single beam echo sounder. So an echo sounder with just a single beam that's transmitted down, it gives us fairly dense breadcrumbs along a single trail. And now with revolutions in science and physics, we have not just one of these, but many of these all arranged in a single sound source and listening source that paint large swaths of the ocean. And in so doing, you can actually get very good 3D representations of the sea floor. So if we were to examine, say, the Durban harbour floor, you can pick up things as small as a teacup if you're willing to take the time and the energy to process that data sufficiently. So this is really a revolution. What it looks like, I've got a little video here, which they never seem to work. Oh, the computer gods be praised, this is working. Basically, the ship moves along in coast parallel lines. We paint the seafloor with sound. We move and make sure that all of those lines match up so you can see that swath. And what this does is it allows us to map seafloor structure, map seafloor composition. So we can know what the seafloor looks like and what the seafloor is perhaps made like based on the scattering potential of that sound. This allows us to assess things like other environmental factors, so sediment movements, hazards to things such as pipeline and cable laying, communication cables. So this is critical. And in particular, it's critical as we move forward in terms of realizing our blue economic potential. Likewise, we use seismic. So those of you that are familiar with this, we beam a sound beam down to the ocean floor, as you can see here, from a sound source. This penetrates the ocean floor and bounces off a series of layers of different sediments, of different densities or rock layers. And it produces a picture that looks like this. So all of these stripes are ultimately density contrasts within a variety of rocks or sediments. And it shows us, number one, what the subseafloor structure is. So we can strip off sediment and look at what the seafloor might have looked like 10, 20,000 years ago, going all the way back with oil and gas industry standards to millions of years ago. It gives us depth to bedrock. It allows us to work out age relationships of various things. So you can see where we have deposits overlying other deposits. Those must have come after the underlying deposits were first laid down. So age relationships can be established, as well as, again, other environmental factors such as pipeline monitoring, etc. And these other environmental factors are really important because the Department of Science and Technology has put it as part of their mandates to increase and unlock our blue economic potential, and marine geology is ultimately the key that's going to allow us to do that. So where do we go in terms of the future of marine geology? And I think I stole this out of my first year environmental management textbook. So we have environmental concerns, social concerns, and economic concerns. All of these obviously meet in the middle for a happy medium. And I'm going to show you now where I feel that I have a vision in terms of where we can take marine geology in the future for Southern Africa and feed across the whole of Africa that marries all three of these together. And I'm going to do this with the illustration of a few of the projects that we've been doing that relate to submerged shorelines. So exactly like you'd walk along the beach or the shore today on a modern day coastline, these are coastlines that are preserved on the seafloor as relict coastal deposits. So these are sitting on the seafloor and have been stranded in place. And the stranding in place allows us to start to unravel the history behind how these shorelines might have formed. It's very important because they form at lower than present sea levels. So what can they tell us about these lower than present sea levels? Very little is known about sea level below where we stand at present, mean sea level today, because it's so difficult to investigate that. It's expensive, it's time consuming, and it's costly from a resource perspective. What can they also reveal about coastal behavior in the context of sea level rise? So I can look at these shorelines and I can understand what the context was in which these shorelines were developing. It tells me how the coasts were behaving a certain number of years in the past, and then how these things interact with rising sea level. Hopefully then this will allow us to give us knowledge in the future. So we can see back in the past and extrapolate that past knowledge to what we might expect in terms of coastal planning for future scenarios with things such as climate change and rising sea level. So this example over here on the bottom right is a really nice example. We can see all of these irregularities on the sea floor here. This is a sun-shaded image taken obliquely offshore of Durban Harbour. You can see out here we've got a very strong reef. So this is basically a paleo shoreline out here, or a relic deposit. And behind us, we've got all these unusual semicircular features. These are basically coastal lake systems that have been preserved down there. So you're looking at, if you guys are familiar with something like Cozy Bay or Lake Sabaya or Lake St. Lucia, that was sitting down here at the seafloor, roughly when sea level is occupying a depth of about 60 meters. And I'm going to focus now at this 60-meter depth interval when sea levels were there. And we're going to talk about some examples. So let's take you through a few. Richards Bay is a really good example. So the midpoint of the east coast of South Africa, at 60 meters depth, we find Holocene age beaches that are preserved, and they're configured in log spiral bays. And so that's important. A log spiral bay, that's much the same as, say, Durban Bay that you look at from an air photo perhaps. And these things point to there being a really strong equilibrium between sea level and between the supply of sediment to the coast and to the wave energy and oceanic conditions that are operating in that area. Much like there's an equilibrium today producing these types of features. And so I'm going to draw your attention here. We can see this ridge in a classic sort of logarithmic spiral shape. And if I were to overlay an image directly over that of a contemporary log spiral bay, which is from Jessa Point in Sodwana, we see that these things match almost perfectly in terms of the shape and the size. If we look at these in seismic profile, so we can see this sort of feature that sticks out. This is part of this ridge that sticks out here. We can map this along, and we see this occurring at 60 meters. So we see that at 60 meters, there was a sea level that must have been quite stable in equilibrium with all of the various sediment supplies and energy conditions that were operating. If we move slightly further on and we go down now to East London, so that's the southeastmost point of the East Coast. This is an interesting place in that we see a whole series of cliff lines that are developed at 60 meters. So this is a cliff that's been cut into rocks that are of Gondwana age. So these are Peru supergroup rocks or sedimentary rocks. We can see a whole series of log spiral bays again and embayments. So these are three-dimensional pictures of the seafloor with the depths and artificial shading. Over here, we can see a river that's cut through, and on the side, this is what we refer to as a parabolic dune. So if you've ever been to Cape Vidal or any of those places where you see these enormous dunes that occur on the Maputoland coastline, that's exactly what was sitting offshore there. Massive set of dunes that were occurring along the seabed. And it's quite interesting is if we extend our gaze to the on-land areas, there are no dunes developed to that size along the East London coast at all. So we've had a major change in the coastline as it's evolved from when sea level was at 60 meters to where it is at present. Again, if I put some overlays on just to convince you guys, so I'm not just making a scientific arm wave here, these things are exactly the same shape and size as some of the local cliffs. So that's a picture from Morgan Bay just up the road from East London. So really we're looking at a coastline submerged on the shelf. So lastly, I think for our last 60-meter depth interval, we found this really unusual feature off the south of Durban. So this is a compilation of high-resolution multi-beam data, naval data that's been collected over the years, and some single-beam data that's been collected with a little single-beam echo sounder. What we see is we can see an elongate feature here with a branching head. Looks almost like a little bit of cauliflower. I've drawn a sketch here to help everybody see this a little bit better. This is what we refer to as a drumstick barrier island. So like a chicken drumstick, it widens at the end. And these things again form under very, very stable conditions with sea level, wave energy, and sediment supply. So really denoting that sea level sat at 60 meters for quite some time. We've not yet sampled this, we haven't yet dated it, but again, we're presuming that this must be Holocene in age. Again, there we have a good example, that's Bull Island from North Carolina, and that exactly fits the shape and scale, maybe with a little bit of scientific liberty, of the barrier island that we see on the seafloor there. So this is what we've mapped. I've mapped this now with multi-beam data as well as a lot of seismic data, a very, very dense grid of seismic data across here over the years. And we can see this red line is the shoreline. We can see we have what looks to be a bluff. So the point, southern point of Durban, that's sitting now probably about 20 kilometers to the northeast of where that actually sits at present. This kinks inwards. We've got some unusual bifurcation here, and this goes on up all the way up to Richards Bay. We can see this major coastal inflection point here where the Tidal River comes in, actually is mirrored out here, sitting now probably about 40 kilometers to the south. So a very, very different looking environment and scenery compared to what it is at present. And I'm going to take your guys' attention here. This is very unusual, and I thought this was really cool. I was talking to my father-in-law about this the other day. So if we look here, and I hope you can see underneath this little screen here, anyway, if we look, you can see this is Durban Bay. You can see there's a front ridge here. This is the Durban Bluff, which is made of a big calcareous sandstone. And behind it, we have a back barrier shoreline that's developed. If I look, here's a, I'm just going to move this. If I look, here's the barrier here, and there's the back barrier there. And inside here, we've got a whole series of little channels that have been formed through wetlands and marshes and lagoons as this was filled up and Durban Bay was produced. If I get a cross section through here, I see we've got a shoreline at the back and a shoreline at the front, very similar to what we appear to have in Durban Bay. And then inside here, we've got this really anomalous material that's full of all little bits of incisions here and there, nice low reflectivity material. And what this is, I believe, is something akin to the modern Durban Bay. So we can see here, this is a lovely multi-beam map that was created by Dr. Peter Ramsey and his first-world company, Marine Geosolutions. We can see a series of tidal channels that have come through here and creeks, low points. Not just all of this is maintained through dredging. And this looks what I would imagine if we took a cross-section through here, this looks like. If we actually look at modern-day seismic lines through here now, we see again similar types of features that are formed. So what this implies is that we had a situation like this sitting now somewhere off the Mvoti River, off Salt Rock, a giant Durban Bay occurring when sea levels were 60 meters below. If we take it slightly shallower, and I think this is quite interesting, so offshore the largest river on the east coast of South Africa, that's the Tugela River, we find a series of drowned Holocene age deltas. So we've called these and dated these. They're Holocene in age and they've been drowned in place. Well, if we look at the modern day Tugela River, there's no delta that's formed here. There's not big lobes of material. That's because the wave energy is so intense and aggressive. So this is pointing to some unusual happenings occurring when this was deposited and then when this was left behind as sea level rose up. So these drowned Holocene age deltas, if we look at them, they show multiple stages of delta backstepping. So deltas only backstep if you limit the supply of sediment or if you move sea level quite dramatically landwards. So keep that in mind. If we go to Allowal Shoal, if any of you are scuba divers, you'll have been there, you'll know what Allowal Shoal looks like. Beautiful place to dive. A depth of about 40 to 35 meters. There's a map that was made as a promotional thing by Environmental Mapping and Surveying, a really cool map. You can see again, we have this unusual drumstick-like feature. So another drumstick barrier that's formed. You can see it very clearly here. And seaward of this, we've got what appears to be the landward edge of some form of drowned lagoon. So really, again, an interesting area. We had a coastline forming here, likewise with the deltas at about 40 to 35 meters water depth. And lastly, I think this is one of the coolest things. If we go off the Kai River, so the Eastern Cape, which is I think my most favorite place in South Africa, we can see a whole series of unusual bits in the seafloor. And if we look at the interpretation of this, what we interpret this to be is right out seawards here at 100 meters, we have barrier islands. We don't get barrier islands forming here. We have barrier islands forming in southern Mozambique. They're very prevalent along the Gulf of Mexico and the US Atlantic. Big barrier islands, big accumulations of sediments, inlets. We can see rivers that have flowed through here, little tidal creeks. We can see meander bars, that sort of thing. It's likely seaward of this where we had a 60-meter shoreline. So when sea levels are at 60 meters, we have these enormous dunes that had developed. And again, I raised this a little earlier. These dunes do not occur on the modern day coast. And when we map out this dune field was the size of equal to, if not bigger than the Alexandria dune field in Port Elizabeth, which is, I think, and I could be corrected, the largest dune field in Southern Africa. So an immense amount of sediment used to sit out on the shelf when sea level was occupying that 60-meter mark. So why do we really care so much about this? And I took this photograph when I was flying over Greenland last year sometime. I've never seen anything so cool. This is why you fight for the window seat, I guess. You can see here a series of glaciers and all of the icebergs that are carving off of these and being transported off. So we are causing our ice caps to melt. And that's important because what we're seeing on the seafloor are observations that provide constraints on, firstly, very slowly rising and stable sea level, which is when we formed all these features at about the 30-meter somewhat mark, about the 60-meter mark here and there. So this should actually be a bit lower. This is the 30 to 40-meter mark here. There's another one a little bit up. So very slowly rising sea levels, but these are interspersed with things called meltwater pulses, which relates to that glacial melting, catastrophic collapsing of the global ice sheets. So the Laurentide ice sheets to the north funneled massive quantities of seawater into the global oceans as they melted in the past. And this caused major jumps in sea level. So there was one occurring roughly from 100 meters. I don't have that here. Then we have really good timing and date constraints for this meltwater pulse here from about 60 meters up to about 45 meters water depth. So if you can imagine, this is an order of magnitude greater than what we're experiencing now, and we're panicking about climate change at the current moment in time. This gives us a glimpse into how our coastline might respond to further catastrophic ice sheet collapses. If we are going to face the next major rise in sea level, I mean a serious major rise in sea level in terms of its rate, this gives us an idea of how something like this lovely log spiral bay, which is Durban's coastline, you can see all this lovely development here, beautiful unnatural sandy beach. How will this respond if we were to suddenly raise sea level? Can this adjust in time and keep pace as sea level rises, or will it be left behind? And I can guarantee you guys, with the amount of engineering that's occurred here, this is long gone. This will just be drowned in place. There'll never be a motion where this beach migrates backwards, and the Golden Mile, unfortunately, I think is going to end up the soggy bottom of KwaZulu-Natal. Who knows when this will be, but it's definitely a certainty. And importantly, from an academic perspective, this allows us to constrain post-glacial sea levels. So those are sea levels that have been occurring once the ice sheets have begun melting from about 18,000 years ago in what we refer to as far-field sites. So sites that are not subjected to glaciations. So it's been a very long time since South Africa had glaciers. And so we consider this a far-field site. Isostasy, so the movement, the vertical movement of land as we unload from glaciers is not a problem here. And we're tectonically stable. So it's an excellent place to start to constrain paleo sea levels. Let's take a quick cruise across to the west coast. So this is an interesting area, and I think we have some colleagues that have joined us from NAMDEB here. So if we focus here, we find very interesting seafloor features. And we're going to go from what is probably a societal aspect in terms of looking at economics and society now to a proper economic aspect. So we're looking here at a project that's run with Anglo American. We've got a number of colleagues there at NAMDEB themselves, as well as colleagues from overseas, from other universities. And we've been looking at these really interesting seafloor features in an area called the Sperrgebiet. Sperrgebiet translates from German into the forbidden area. And this is why it's forbidden. So that's an actual wave. My wife said she thought that was a cloud at first. No, those are breaking waves. This is the shore face. So this is the area basically where waves begin to shoal and break. So it's 100 meters or two from the beach. You can see scale. It's like a fairly large wave in the background there. This is a very challenging place to collect marine geophysical data. It's colleagues at NAMDEB have done such amazing jobs at this. I think it's a world-class program that they've been running. We've collected some amazing stuff. So if we look at this seismic line here, we can see all these squiggles. And I know for most of you, this is just all squiggles, but for a trained eye, we can see these unusual lumpy seafloor features buried by about 20 meters of sediment. These are shorelines, and these are the shorelines that mark diamondiferous collection and deposition. If we look at the onshore equivalents, these are exactly what we see here on the left. A series of gravel spits, a big cobble and pebble and boulder spits that are preserved on the seafloor. When these things are cored, when we examine them from a seismic perspective, we see they look very similar in terms of the internal architecture. And this is the kind of material that we expect to be finding in there. And that's also the kind of material that you'd expect to be finding your diamonds. So this is a key thing in terms of NAMDEB's program, in terms of coastal mining and the extension of the mining plan further seawards. And I believe this has extended a lot of the life of mine currently in terms of NAMDEB's operations, which is great. So where to from here? Well, obviously we're looking now at a variety of different perspectives. So economic, social, environmental, we also work together with marine ecologists, habitat mapping. And I think the only way from here is upwards. So we hope to grow, and we hope to grow in staff. So myself and Nku, our developmental lecturer, Nku Ledladla, obviously would like more people to join with us in different aspects of marine geology, from aeolian and coastal geomorphology all the way through to deep marine geology. We'd like to grow in collaborators, and we'd like to grow in an international student cohort, as well as African cohort. So we're hoping to establish a center of excellence in African marine geology. And I think we're a long way there in terms of the key scientific outputs that we've been doing, the student graduations, the equipment that we built up, as well as the data sets that we are now handling and managing. So I think the sky is the limit, and this is top of very good news that I just received between the Petroleum Agency of South Africa. So they have an upstream training initiative where they fund projects, and they funded our project that I applied for, which is, I call it MARTRAP. So you trap the students in there. It's the Marine Training Program, of which it's an offshore marine geophysics course. It will be taught over 2 weeks. So we collect new data, we train students, we produce data sets for higher level students to work off, all going towards strengthening our foothold as marine geologists within our blue economy. I'm very, very excited about that. So what to expect? Well, I can tell you now that you don't expect this. So in all the years that I've been doing this, I think I started on the rustiest vessels where if you just looked at it wrong, you caught a case of lockjaw. So this is something that happens once in a blue moon. Mostly you deal with things like this, hippos that are cruising into the surf zone. So in particular, I'm going to focus here on some of the stuff that we've dealt with together with Professor Mark Humphreys at BITS and our coastal studies and our shallow water body studies. Here you see hippos going out. So this is at Cape Tidal. Here's Mark himself just spending some time not doing field work and instead catching a crocodile. Don't ask me why. But you know, these are the dangers. You'll be sitting on your coring barge, turning around and noticing a croc gnawing away at your anchor rope. This is some of the seismic data collecting. So this is definitely not what our German colleagues have in mind when they think of seismic data collection. Here we have the most expensive seismic array ever. One boat towing another boat towing a seismic array out here, collecting data in Lake St. Lucia. Here we are, and I believe that's one Benelux sitting, for shame, in the swamps of the Mkuzi Delta, coring for paleoclimate reconstructions. You can see it's a muddy business. And the last time we were there, I was assured by Professor Humphreys there were no hippos there, and we managed to encounter a series of hippo footprints. So I don't believe a word he says, unless it's about paleoclimate. So there's a lot of adventures to be had, and I think I'd like to close off this talk with the greatest adventure I've had, which is this is going to be my forthcoming paper in Nature or Science. So if we look here on the screen, this is a seismic line. We can see these unusual reflections that are coming down. We call this a hyperbola or diffraction. Basically, you see these when you come across a really hard object on the seafloor or like a fault or a big block of rock or something. And we were trawling around in Lake St. Lucia. We saw this coming up. We were all very impressed because we thought we'd gone over something geologically cool. And what you're seeing here, folks, is the very first seismic facies of Hippopotamus amphibius. We managed to crawl in about 3 meters of water over a hippo that was sitting on the bottom with this exact boat and this exact setup. You can't imagine this little boat actually getting much faster than probably 10 k's an hour, unless Mark Humphreys is driving it, then it's going at the speed of light. But anyway, so this is, I think, my only shot to get into nature. We all know how easy that is. So hopefully won't be seeing too many of these in the future. And with that, I'd like to say thank you very much for your time and attention. And I'd like to thank the following people. You can read it. I'm sure you don't need to hear any more of my dulcet tones. I think we can open the floor to any questions.
Thanks so much. That was really, really fascinating. Are there any questions for Andrew? Comments?
Andy, I've got a question. In the context of some fairly significant gas condensate discoveries on the south coast of South Africa, what sort of engagement are we starting to see from oil and gas companies in South Africa in terms of concerted effort to fund universities in the direction of petroleum geosciences studies that may be of benefit to the economy or to the companies or to whoever?
Oh, that's an interesting question. So the big funding that was given in the past was to the University of the Western Cape for their petroleum studies, you know, their masters in petroleum exploration. But on the whole, trying to partner with, you know, individual agencies is very difficult unless you've got somebody associated there. And then in many ways too, PASA becomes the, I guess, the part owner of the data. And so everything gets directed through them. I find that, you know, either getting data sets or getting funding is much easier. We're going through colleagues in Mozambique, so like ENI and Total and those guys, because they're actually very willing to support research. There's many data sets that we actually have at the moment looking at Tanzania and northern Mozambique from all sorts of things. So actual like kind of methogenic carbonates that are being precipitated in shallow marine environments, really cool stuff that they are very happy to throw data sets at. You know, we don't have to, you know, pass through the eye of a needle, so to speak. Price is not too bad, but you know, with many of the companies, there's embargoes and things, and it's just, for me, it's just been a frustration, which is why I've actually turned my attention more so from where I started, which was the slope and kind of the outer shelf into the shelf waters, is because, you know, that's perhaps more applicable to things like the the diamond industry or the marine placer industry.
Interesting, yeah. seems a huge opportunity for potential funding, which should be an obligation, I suppose, of these companies moving into countries that this seems to fall by the wayside in terms of making its way to government.
I mean, I think this initiative now with the Upstream Training Trust has been, for me, a direct benefit. So this is going to train students. So we're going to systematically for the next 5 years map gaps in the shelf that we haven't mapped. So we'll stick with probably the narrow shelves just because it's easier to map and it's, I think, more interesting. And I think that's a huge benefit. I'm very, very grateful to Pastor. He's done an excellent job with that.
Mm-hmm.
Hi, Andrew. Peter Ramsey here from the US. Great presentation. It's fantastic that you've managed to assemble all of these data sets, and certainly for me, looking at your interpretation of the data set, you're absolutely amazing in what you've achieved. You've seen things in those data sets that obviously I was quite familiar with, that I would never have dreamed that you could get that much information out of them. Just congratulations, and your contributions to marine geology in South Africa are nothing short of astounding.
Yo, Pete, thank you so much. It all began with you employing a nitwit who walked into your office in 2001 and asked for a job. And you'll never look back. I'll never be able to thank you enough.
Probably one of the best decisions I ever made.
Hayley, you have a question?
Yeah, hi, good afternoon, everyone. It's Hayley Quaternary from Council for Geoscience. Yeah, thanks very much, Andy, for an interesting talk. It's great to see what you and your team are up to. Congratulations as well on your new course and funding. I think that's excellent to hear that petroleum training is going to start at UKZN. I just wanted to say, obviously, we've worked mostly in the Cape at the Council for Geoscience, but I wanted to just pick up on the comments that you made about marine geoscience being governmentally non-recognized for the most part. And yeah, since the Operation Pakisa Oceans Economy, this is somewhat changing pretty rapidly. And marine geosciences are making their way into policy development now in various government departments, which is really good for the country. We also have an active and pretty well supported new mapping program at the CGS since 2018. So it's good to see that across the coastline and for the most part all over the place, that things are happening here in South Africa. And yeah, I just wanted to say that it's really an exciting time and place for us to be doing this kind of work. So yeah, thanks for that.
Well, thanks, Hayley. Yeah, I think that's exactly it. It's now time to strike while the iron is hot. So to produce graduates that have the skills, that's my emphasis. That's been not from governmental things from management side, but governmental mandates to universities. There's been no real drive to produce graduates in marine geology for a very long time. And hopefully that's what's changing now.
Yeah, I fully agree. And yeah, I wish you all the best now that there's a formalized program. I think it's excellent.
Thanks, Andy. Before you ask a question, I'm just going to launch a quick poll to see where our delegates are from. I see quite a few people are leaving. Andy, if you'd like to ask your question now.
Andy, it's Andy Emery here. Fascinating talk. Some beautiful geomorphology going on down there. Just wondering if there's much interest in offshore wind around the coast of various southern African countries. I wonder if there's any suitable shelf areas for offshore wind, and if there's any rumblings within the industry of offshore wind.
So, young, I should say, Dr. Emery, congratulations to you.
Thanks very much.
When I read your paper in marine geology, obviously they got me thinking about wind and wind energy and how we could use that to start collecting extra data. To be honest, our major power supplier, and no offense to anyone logging here from Eskom, has a hard enough time keeping the lights on with the coal, let alone expanding into renewables. So there was a program looking at renewables, a brief one, harnessing the Gullis current. So some of the data sets that I actually presented were data sets collected for that, in terms of trying to find a place for moorings on the seabed. Andy, it's tough to say because it's just such an aggressive coastline with wave activity. I don't know how well things would anchor, and I just don't know how far ahead our government's thinking in terms of renewables anyway. I could be wrong. I could be just talking well out of hand here, but I would really hope that this is something that would be forthcoming, because, you know, gee, you look at those beautiful data sets that you guys are working with at Leeds, and, you know, I get so envious. And not only that, I think it just really is a sustainable way in which we can produce energy. I'm hoping that will be something in the future, but I can't give you a definitive yay or nay, unfortunately.
Yeah, no worries. It's certainly expanding very rapidly in Europe and America and places like China, and very keen on offshore wind. But as you say, the coastline there is quite potentially quite difficult for fixed foundation offshore wind turbines, and probably also floating turbines as well. But yeah, keep your eyes out for that. There might be some interest in the near future, and you might get some really lovely data sets out of it.
Yourself a visit to South Africa, that'd be great.
Yeah.
Are there any other questions?
I'm for a beer. Or...
That sounds great.
Well done, Andy. I think that was absolutely fantastic.
So you're gonna, I do believe it's 5 o'clock somewhere. So
20 to 1, yeah.
And as you can see, all the guys in Australia have already headed off to the pub.
Yeah.
For their 2Ds extra dry.
Yeah.
Yes, exactly.
Yeah.
Great.
Andy, are you going to make any of this content available? I really quite liked a lot of the imagery and studies.
This should be on the GSSA YouTube, so given permission for that on the YouTube channel. And then we actually have a paper just in submission now. Hopefully something will pop out of it with a lot of these images. So looking at paleogeography of this 60-meter shoreline. So a lot of those images are from there. So yeah, absolutely, you should be able to get your hands on stuff, no problem.
Sure.
Just a word from me, Craig. I think we need to thank our sponsors for June for this series of lectures, which is Dennis Blewett and GeoExplore SOAR. Nolene, do you have anything more before we close out the meeting?
Nothing else. Thanks everybody for joining us, and we'll see you again next week.
I'll close the meeting now. Thank you all.
Thank you. Thanks, everyone.
Thanks, Andy.
Thanks, Andy.
Thank you.
Ciao.
Cheers.